This is the day 2 video for solving linear systems of equations by graphing. So on the day 1 video and in class on day 1, we talked about the fact that there were 3 different types of solutions that you might see when you're solving systems. So I'm going to go into a little more detail about that today. And as you can see with our first system that we have here, not all of our equations are going to be written in slope-intercept form to start with. So I am going to go ahead and change this first equation that I've got here into slope-intercept form just to make it a little bit easier to graph. Now you could always graph this using intercepts, but I know most of you prefer slope-intercept form, and I showed you how to do that on the calculator as well, so that's what we're going to stick with in this video. So for this equation, I have x plus 2y equals 4, and I'm trying to isolate y. So the opposite of positive x is to subtract x from both sides. When I do that, the x's will cancel and I'm left with 2y equals negative x plus 4. Then from there, I need to divide every piece of the equation by 2 because that's the opposite of multiplying, which was what was happening there with y. So now I have y equals negative half x, and then 4 divided by 2 is positive 2. Now at this point, hopefully you guys are looking at these equations and you're seeing, wow, this second equation is y equals negative half x plus 2, which I forgot the x. Let's go ahead and put that in there. And then this second equation is also negative half x plus 2. So we have the same equation twice within our system. So if you look at what that would look like if I graphed it, you would only see one line on my coordinate plane, because step 1 is to place your first point on your y-intercept, which is 2, so I would place a point on 2. And then step 2, I'm using that slope, I'm going to go down 1 over 2, or I could go up 1, left 2, and then I have my line. Well, if I did that for my first equation, and then I do that for my second equation, I have 2 lines graphed on top of one another. When that happens, that means that you would have an infinite number of solutions, because remember, your solution to your system is where the lines are intersecting. And if they're the exact same line, then that means they're intersecting everywhere. So the answer that you're looking for is that it has an infinite number of solutions. Now, I didn't actually have to graph that in order to know that, because as soon as I saw that the equations were the same, I knew that I was going to have an infinite number of solutions. Remember, that type of system is called a consistent dependent system, which I reviewed with you guys on day 1. Okay, so let's look at another system. So this system, just like the last one of my equations is already set up in slope-intercept form for me, all nice and neat, but the other equation needs a little manipulation. So I'm going to take this equation, and the first thing that I'm going to do to isolate y is I'm going to subtract x from both sides. Remember, you are always doing the opposite of what they're doing. So that gives me negative y equals negative x plus 2. Then in order to get y by itself, I'm dividing everything by negative 1 to undo that negative y. That gives me y equals positive x minus 2. Now at this point, I'm looking at equation 1 and equation 2 within my system, and I notice that these lines have the same slope. Notice the slope on both of these lines is positive 1, but they have different y-intercepts. So some of you may remember that that means that these are going to be parallel, while others of you need to take that next step and look at the graph. So let's go ahead and look at that graph. The graph would be 2 lines that are parallel. This top line right here is x plus 5, and this bottom line is y equals x minus 2. Notice the y-intercepts are visible on my graph. And these lines, because they are parallel, are never going to intersect. Since they never are going to intersect, I know that this system has no solution. You need to remember that you have to talk about the solution because we're solving the system by graphing. So if they're never going to intersect, you can't just leave it blank. You need to say there's no solution. There is not a point at which these two lines are going to cross, nor will these two equations ever be equal to one another. Okay, so we have one more system to talk about here, and it's also a slight variation. We talked a lot yesterday about vertical and horizontal lines, which notice right here I have x equals -2. When you see an equation that only has one variable, you want to use those acronyms that I was talking to you about. So if x equals -2, that would be VUX. Remember, x equals, so I want x to be in my acronym. So I know that this is going to make a vertical line that passes through -2. Okay, so we're going to look at the graph in just a moment, but I just wanted to review that first. Let's go ahead and look at that second equation. We need to manipulate it a little bit. So I'm getting y by itself, so I'm going to subtract 3x from both sides. I'm going to bring down my -2y. And then I'm going to divide everything by -2 in order to get y alone. Some of you made a few mistakes today. Don't forget, if you have a -3 over a -2, that becomes +3 over 2x. And then -18 divided by -2 makes +9. So at this point, I'm going to take this equation and then my first equation, and I'm going to graph them on the coordinate plane to look at it. So as I already said, x equals -2 is going to be a vertical line passing through -2 on the x-axis. And then I've taken our equation y equals 3 over 2x plus 9, and I've graphed that as well. So my y-intercept was 9. I would go down 3 and to the left 2, or I could go up 3 and to the right 2, and that's how I got my line. Now remember, I'm looking for the point of intersection. Now my x equals -2 line is a little, wide here for you guys, but you can see that these lines intersect right there. And the coordinate of that point is -2, 6, which is actually my solution. So some of you were asking me, how do I get the coordinates or the ordered pair? So what I'm doing is I'm going over 2 left, so that's where the -2 comes from, and I would go up 6 in order to get to that point where the lines are crossing. So the x coordinate is -2, the y coordinate is 6. That is the point at which these two equations are equal, and visually that is where the two lines intersect. Okay, so I did give you a homework assignment to complete over this. We've been working on it a little bit in class. You should be completing homework number 1. You're doing problems 1, 2, 3, number 5, 7, 8, and 10. And then I do want you to answer those 3 questions at the bottom of the assignment. If you guys have any questions, please come in for tutoring. If this video did not give you enough support, then I will see you in tutoring in the morning, and I will see you tomorrow in class otherwise. Have a great day.